Hello everyone, welcome back to Stepping Up. Today, we are delving into the fascinating world of memory management and garbage collection in Java. In the next 10 minutes, I will demystify how Java handles memory and keeps your program running smoothly. If you are new here, make sure to hit the subscribe button. And if you are ready to dive into the intricacy of the memory management, give this video a thumbs up. And if you have any query, please write down in the comment below. So first, the topic that we are covering today. This is Introduction to Memory Management, Java Memory Model, Garbage Collection Basics, Types of Garbage Collector, Memory Leaks and Preventions, Best Practice of Memory Management. Let's start with first the definition of memory management. Memory management in Java involves the allocations and deallocation of memory resources for objects during the program's execution. It plays crucial role in ensuring optimal performance and resource utilizations. So memory management, it plays important role while working in programming. It is how your program allocate and deallocate the memory during runtime. And the difference between the stack and the heap, how Java utilize both different purpose. So it is very important in this case. So memory management is there. So for that we are using this memory management. It has various advantages or importance. It prevents the memory leaks, efficient resource allocations, ensuring application stability. So these are the important of that. It prevents these memory leaks and efficient allocations of the resources and application stability. So Java memory is divided into heap and stack. So these are the two models. So heap is where objects are stored and stack where manage the invocations. So these are the two methods. So it's important to know where we are using the means that is memory properly. Understanding the difference between stack and heap and how utilize it different. Next is also we have garbage collection in Java, that automatic memory management process. It identify, clears, unreferenced objects to free up the memories. This is also very important. It works on the various phases of garbage collection: mark and sweep, compact, and more. So we have various steps for that. If we talk about garbage collection in Java, it is the process by which Java programs perform automatic memory management. It compiles to bytecodes and can be run on Java Virtual Machine JVM. When the Java programs runs to JVM, objects are created on the heap, which is a portion of memory dedicated to the program. And eventually some objects will no longer be needed. So garbage collector finds these unused objects and deletes them to free up the memory for the memory management purpose. So there is garbage collection. It is the process of automatically identifying and reclaiming the memory occupied by the objects that are no longer in use. Java.lang.objects provides a finalized methods that can be overridden for the custom cleanup purpose. In C or C++, a programmer is responsible for both the creation and destruction of objects. It's upon us during programming, is it required or not, we can create or destruct. And programmer neglect the destructions of useless objects. So due to this negligence, at certain points, sufficient memory may not be available to create the new objects. An entire program will terminate abnormally, causing out of memory error in there. But in Java, the programmer need not to care for all these problems for those objects. They are no longer in use. So we don't have to take care, we don't have to remember, because there is garbage collection. Garbage collector destroy these objects. The main objective of this is to free up the heap memory by destroying unreachable objects. And it is best example is the daemon thread, as it is always running in the background to check the whatever the objects we are not using, unreachable object, it clean up directly in order to for the memory management. So our garbage collection, it is an automatic garbage process that is looking at the heap memory, identifying the object that is in use or not, deleting the unused objects. And use objects, reference objects, use objects that are these are some part of your program still remain in the pointer, and the unused or unreferenced objects no longer reference in any part of your programs. So memory use unreferenced object can be reclaimed. The memory does not need to mark object to be deleted explicitly. So garbage collection is implemented live in JVM. So that's the role of garbage collections. So I think that's clear. Now next is types of garbage collector. There is serial collector, parallel collectors, concrete mark sweep collectors, or G1 garbage collectors. So these are various types. Minor or incremental garbage collectors, these are unreachables or some are reachable. So like that there is various types of garbage collectors. So they have their own role. The main purpose is same. They clean up the unreached object and they are inbuilt in JVM. So these are the different types of Java collectors. Now next is the example, like using a G1 character we have. So it is java.xjar application.jar. We are using inside that jar file. So this jar file is inserted. So it works on JVM inbuilt. So it helps us to properly manage our memory. Memory leaks and prevention. So memory leaks occurs when the objects are not properly deallocated, leading to excessive memory consumptions. Preventions involves careful resource management, avoiding unnecessary object retentions. So for that, memory leaks and prevention is there. So memory leaks, it occurs when the objects are not properly deallocated. Excessive memory of consumption. Prevention, careful resource management. So these are the definition of this memory leaks and prevention. Common causes of memory leaks is unintentional object reference. We unintentionally reference the objects that are not linked, or unclose the resource file stream, like we are not using the close files. I always say please you close the file input output streams and all in order to prevent the memory leak. So if we are not unclosed, they are unclosed resources, so that causes the memory leaks. Large object caches are there that also cause the memory leaks. Best practice in memory management is to minimize the object creations. Use appropriate data structure. So what we know the application, what we require, what we have to do, what type of means collections we require or data structure. So use properly, use appropriate data structure, appropriate collections frameworks, and minimize the object creations. Profile and analyze the memory uses. Regularly review and optimize the code. So first don't start writing the code as you get the task. First analyze whatever I require, how many class I create, how many methods I create, how they are interrelated, how we analyze the memory management and all. So this is the best practice of memory management. Next is the example, avoid unnecessary object retention, like string results this, int, and this up to this, and the value we are writing. So avoid unnecessary object creation. So this is the not required of this results to create. It already we can get here also. So unnecessary object creation, please try to remove that. Next is garbage collection tuning. Garbage collection tuning, it provides the options for tuning the garbage collections. Parameters XMS, these sets the initial or maximum heap size. So we in the jar file also we insert, so that we can garbage collection tuning we can fix. Next is the benefit of efficient memory management. So we are doing this. What is the benefit of that? We have seen the role of garbage collection, and they are very helpful. What are their types? We have seen these. There are various types. What are their basic roles? So the best of efficient is improve the application performance. The application will not hang if we will get the output, because there is no extra things. It reduce the risks of memory related issue, so that risk also reduced. Better scalability, we can enhance also, we can make it work properly. So better scalability purpose. So these are all the efficient benefit of the memory management. So we have to follow all the rules in order to get the efficient output. So that's all about all the topics of garbage collection and that is memory management. In this journey through memory management and garbage collection, we have covered the basic, delve into the garbage collection process, explore the object life cycle, and discuss memory leaks, even as the tuning of the garbage collections. You are now armed with the knowledge to manage the memory effectively in your job program. If understanding memory management brought clarity to your coding journey, hit the like button, share it to your coding buddies, and subscribe for more Java Mastery. Happy coding and stay healthy. Thank you.